I would collect the arithmetic one, right? Oh, is it today? I'm doing tomorrow. Today? Okay, I'll grab it for you. Not a problem. Just a second, I'll grab that. All right. So anyway, I said the arithmetic handout was due, didn't I? I'd collect it right now. I was lying, it turned out. I actually realized it about an hour ago. I can't take that from you. You got to have it to look over for the final. So I'll take it on the final. So I really mean it this time. So I'll take it on the final. So hold on to it. Give it to me and this one, both of them, Monday on the final. I'll take them both, grade them both, get them back to you. I don't want to take it out of your hand right before you take the final. I want you to have it to look over. There's no other day I could get it back to you before the final. That just hit me about an hour ago, so I can't take it from you. So keep it in case you want to look it over for the final. I'll take them both. Both handouts then will be due on Monday. Both handouts on Monday. All right. Well, so our plan for the day is to crank through this geometric sequence and series handout, and then talk a little bit about the final. Look back at a couple things that might be helpful, and we are done. Our final is Monday, right? Let me say that first off. Final exam. Have I already talked all about this? Mm-hmm. It's Monday at normal time, right? 1 o'clock. 1 to 3, and yeah, I said what's on it and everything, right? What's the best way to study for it? Just wing it. Just hope for the best. No.
That's what I was going to do.
Yeah, right. Okay. That's why I'm saying this, so that we won't go over practice exams 1 through 5. Right? Well, especially 4. I mean, you just had 5. That's probably pretty fresh in your mind. Might not need to go over that one as much. Whatever you need to do.
Oh, one more quick question. By practice exams, do you mean the?
Yeah, mathexcel.com under the announcements.
Yeah, I was gonna say, ask them either the hardcovers or the online ones.
Announcements. Yeah, and use the YouTube.com, and your favorite site on YouTube, my math lectures, right? Go there. YouTube.com, Brett Heron. Click subscribe and like and really like and whatever else is on there. No, I'm kidding. It doesn't do anything for me. YouTube.com, Brett Heron, and then just because the old, what's it called? The practice exams are there, aren't they? You guys know what I mean, right? Is that okay? All right, is that good? So that's what I would do to get ready for the exam on Monday. I would start like right away, just start cranking through those old practice exams, 1 through, probably not number 5 because that's fresh, especially 1 through 4. And the final will count double, right? Did I talk about that? Final counts as 100 points itself, and it replaces your lowest score, so that's another 100. So it'll end up counting as 200, so it's very valuable. End up counting as 200 points. 100 itself, and then it'll replace the lowest of your other 5 exam scores, counting as another 100. Is that good? So there's opportunity here. If your grade's low and you want to bring it up, you can really help yourself out with the final. To get a good score in the final, it'll count 100 there, and it'll replace that other low score, so you can really help yourself out. Having said that, math finals are not easy. What I mean is, it's the same old problems. It's not harder problems or anything, but it's just hard to remember it all. It's been 18 weeks, hasn't it? It's been a long time. The seasons have changed while we've been in this class, right? Summer went, fall is about gone. Weather's colder. It was hot when we started, August, right? So things have been a long time. We've done a lot of math. You really need to look back. If you just show up Monday without looking back, something bad will happen on Monday. Don't do that. That would not be wise. After all this good work, get all the way to the end, and don't want that to happen. All right, any questions on the final? Is it all good? All make perfect sense?
And you said we get a full page?
Oh, yeah, full page of notes. That's right. Full sheet. Full sheet, both sides. Like this size, right? Full sheet, both sides. For notes, write anything you want, both sides on that. That's right. Good. Put whole examples of problems or whatever. All right. Let's get going. Where are we at? I'm confused. What are we doing? Oh, the handout. Yeah, the handout. This thing. All right, let's get going through this thing. Geometric handout. Here we go. Geometric handout. Okay, we have 3 formulas at the top. Put those in your 3x5. I mean your full sheet of notes for the final. We're going to do about half of it right now, and I'll collect it from you at the final. So they're saying find the 7th term. 7th term of 2, 6, 18, ... All right. Yeah, handouts are, oh, they're right up here, huh? Handouts are right up here. Anybody not get them? They're right here. So they're up here. If anybody didn't get them, there they are. So, okay. So find the 7th term. Now, what's happening from term to term in this list of numbers, a sequence? Yeah, do you see it's going times 3? Times 3, times 3, like that, right? And that's different. I don't know if you noticed. That's different than what was happening in the sequences we looked at on Monday. What was going on from term to term on Monday?
It was just like
It was just adding, or subtracting the same number. So arithmetic. Let me give you an example. An arithmetic adds or subtracts the same number each time. So that would be like 2, 5, 8, 11, ... That would just be adding 3, adding 3, adding 3 every time. But this is a geometric. Geometric, the difference is multiply or divide same number each time. So geometric is a level higher. You're multiplying or dividing every time from number to number, term to term, instead of adding, subtracting. Easy way to remember it, arithmetic is the first thing you did when you were a youngin' in math. That was adding, subtracting, right? So arithmetic sequences are all about adding, subtracting from term to term. Geometric's a little higher level. It's multiplying and dividing the same number each time. Okay, so this is geometric. It's multiplying the same number every time, times 3, times 3. So they want me to go out to the 6th term. Now you could use, or 7th term, huh? You could use the formula if you want to. That's totally fine. But really, if I only need to go out to the 7th term, it's probably easier just to take your calculator, I would think, and go times 3, times 3, times 3, times 3. Right? You with me? Am I making any sense? So in other words, this one went times, this is the first term, second term, third term. So what's the so I need the 4th, 5th, 6th, and 7th. So 4th term times 30, 54, times 3, 50, 162, times 3, 486, and then that one's too big for me.
So where's got to be an easier way to do that?
So I'll look in the back here. It's 1458. There's our answer. We're done. Does that make sense? I just kept on going.
There's got to be an easier way.
There's not an easier way, but you could use, there's another way. You could use the formula. Yeah, I'll do that in a minute. I think this is a lot easier. Is that good on that? Just take calculator, go times 3, times 3, times 3, times 3. You know, from the 18, just 4 more jumps. Good? Let's try number 2. Number 2 says, find the 11th term of 1, negative 2, 4, negative 8, ... Find the 11th term. What's it multiplying by every time? Negative 2, huh? Everybody see it's times negative 2? Times negative 2 times negative 2 times negative 2. So this is the first, second, third, fourth, fifth, 6th, 7th, 8th, 9th, 10th, and 11th. All right, so times needs to be 16, negative 34, plus 64, minus 28, plus 256, minus 512, plus 1,024. Answers are on the back, or the second page, like usual. 1,024. There it is. Good? Is that easy? We all good? I move on from there? Do y'all want me to show you how to use the formula on that one? I can show you how to use the formula too, if you prefer. Let me show you. So let me redo number 2 with the formula. So if you don't want to do that, just do it by hand with a calculator thing. Excuse me. Let's redo the question. So the formula is the A sub n is A1 times R to the n minus 1. There's the formula up there at the top. And so they want 11th. Remember, the ordinals are always n. 11th. So n is 11. So A sub 11 is A1. What's A1 always? First term, huh? Remember that from Monday? A1's always the first term, which is 1, times R. Now, what's R? R is number multiplied each time. R is the number that's being timesed each time.
What does R stand for?
Ratio. So, what is being multiplied every time? Negative 2, huh? It's being multiplied by negative 2 every time. So that's your R. N, again, remember that's 11 minus 1. So here's how you would do it with the formula. So it's 1 times minus 2 to the 10th. Hit the buttons on your calculator. You'll get the same answer, 1,024. So whichever you want. There's formula, or I just did it by hand with the calculator. Times 2, times 2, times 2, times 2. Until I got out there. Either way, let's try number 3. How about the 6th term of 24, 12, 6, Find the 6th term. I don't know, yeah. What do they want? Fraction. Looks like they want a fraction.
It's like times 1/2.
Yeah, or divide by 2. Either way.
Oh.
Yeah, that's right.
Well, if we're using it for multiplication, remember it's going to be multiplied by 1/2.
Correct. Yeah, right. So what's happening from term to term on this one?
It's being divided by 2.
Divided by 2 or multiplied by a half, whichever way you want to say that. Those are two ways to say the same thing. Yeah. Correct. Either way. So it's divide by 2, divide by 2. So divide by 2. So the next one's going to be 3, and then divide by 2, it'll be 3 halves, huh? This is the first. Whoops, the second. First, second, third, fourth, fifth term. Now, how do you take, how do you do that one more time? How do you take 3 halves and divide by 2 again? You multiply the bottom by 2, huh? Does that make sense? Dividing by 2 means multiplying the bottom by 2. Does everybody see that? How am I doing? Am I racing ahead of you, losing you there? So dividing by 2 means multiplying the bottom by 2. Right here. So there it is. The 6th term is 3/4.
Can you just do it like decimals and then convert it up here?
You could. Want to do that?
That's easier.
Sure. That's easier for you. 0.75. Change it back 75 cents, 3/4. Yeah.
I used the formula and it was way shorter.
Okay. Yeah, whichever way you're comfortable with. So I'm just dividing by 2, dividing by 2, dividing by 2. And then with the 3, I put the 2 underneath. And then divide by 2 again. You just do the bottom times 2. Is that okay? Can I move on? Ajane.
How you take out your calculator for number 2? How you put the formula in this way?
Oh, this one? You want to do the formula way? Yeah, you got to put the trick is, did you get like a oh no, it's just -2 with parentheses to the power. You got to use your power button, X to the Y
Oh, I got it.
to the 10th. Or your up arrow.
Yeah, she has the same calculator.
Yeah, up arrow on that one.
Yeah.
Hers looks pink though.
Yeah, she better do that one.
Yeah. All right, we good? We good on all that? All right, on to number 4 we go. Number 4. 8th term of. So we have 222, 0.2. You know what I would do on this one? I would just look at the pattern. Do you see what's happening from number to number there? What's that? Right, I guess you could say that, but that didn't really happen from 2 to 0.2. They didn't really drop a 0. So that won't work everywhere. Is there something we could say that would work everywhere?
Times 0.1.
That's true. Can we say something nicer, though? Yeah, or how about they're just moving the decimal back one place? Isn't that the most user-friendly way to say that? Do you see what I mean by that? See, where was the decimal? If I say the price is $200 for that whatever, where's the decimal? Well, it's at the end. You know that, huh? It's right there. So on the 200, the decimal was right there, wasn't it? And then what happened? The decimal jumped back one spot. Now it's there. Then it jumped back one spot. Now it's really there. Then it jumped back one spot. Now it's before the 2. See what's happening is they're just moving the decimal back one place every time. Make sense? So then this will be 0.02. Now I hope you realize this and this are not the same. Even though they both have an O and a 2, the decimal's in a different spot, isn't it? Right? This has 2 numbers after the decimal. This only has 1. And then move the decimal back again. Move the decimal back again. Are we there? 5th, 6th, 7th, and now 4 zeros and a 2. There we go. We're done.
How would you convert that into a rate, though? Say if you're trying to use
The formula?
yeah.
Yeah, the R is 0.1. We're multiplying by 0.1 every time, which is 1/10. Does that make sense there? See, I just followed the yellow brick road, followed the pattern, just kept moving the decimal back one more place every time on that. Good? All right, so let's keep going on the homework we're doing. So I hope you're copying this down right now on something you can turn in to me on the final, because this is the actual homework assignment that you can turn in to me on Monday, right? In fact, we're doing them all so far. 5. So number 5. They're giving me A1 is 3 and R is 2. They want me to find the nth term formula. So now we'll definitely use the formula. They're asking me to find the formula. So I'll grab the formula at the top of the paper up there. A sub n is A1 times r to the n minus 1. Let's use that one. Okay, and then A1 is 3, the R is 2. So there we go. That's all they really want me to do for the first part. And then the second part is they ask me to find the fifth term. Am I going too quick? Is that good there? So I just plugged in the A1, plugged in the R. Now to find the fifth term, what do I do? Good. Right? You guys getting the hang of that? All these formulas we did, both handouts, the n is the ordinal number, the number that has like fifth or seventh or third. Remember the number that implies an ordering? Right? Y'all catch what I'm saying on that? So that's always your n. Any number that implies it's in a certain order. That would be fifth. That's different than 5. If I say, what place did he come in? 5th place. That's an order. If I just say 5, like 5 people were there, that doesn't imply order. Right? 5th is an ordering. It's what we call an ordinal number. And those are always your n. So just plug that in for n. So right there is an n, a sub 5, and right here's an n. 3 times 2 to the 5 minus 1. And that'll be 3 times 2 to the 4. That'll be 3. Use your calculator. 2 to the 4th is 16. 48. There we go. That's an 8. 48. Anything I can say to help with that? Is that good? Want to try number 6? So use the formula. AN is equal to A1 times R to the n minus 1. A1 is negative 4. R is 3, so there's the formula. And then the second part is they want you to find the fifth term.
3 to the n minus 1?
Yeah. So now plug in the 5 for n. And use your calculator.
That would be a sub 5, right?
Right? Everywhere you got in, you put a 5. Uh-huh. Minus 324?
Yep.
We good on that? minus 324.
So
Yeah.
what's going on with that A and the 5?
A sub n.
Is that just
Oh, yeah, that's
That's
just,
the fifth term.
yeah, we don't have to actually do anything with that. That just means the fifth term is negative 324.
okay?
Yeah, good question. Yeah, you don't do anything with A sub 5 on the left. That's just kind of like the name. It's saying fifth term is whatever answer we get. That's good. Is that good? Is that making sense on that? All right, so you can probably, so I'm going to jump up to number 8 now. You can probably do number 7 on your own. I'm going to jump into number 8. And probably, I don't know, you can just try the same thing. They want the nth term. So there's the A sub n, and then they want you to plug in 5, fifth term. Plug in 5. Is that working out okay? Plug in the 5. Which is minus 2½ to the 4th power. And then 1/2 to the 4th power. Excuse me. How do you take a fraction like 1/2 to the 4th power? Y'all okay with that? Just take the top, go 1 times 1 times 1 times 1. That's going to be 1. The bottom, 2, 2, 2, 2. Like that. And that's 1/16. Is that good? Is everybody okay so far?
Hold on.
I'm racing ahead of you. So minus 2 times 1/16. Right, let me bring it over to here. Now, what do you do when you have a whole number, like minus 2, interacting with a fraction?
Put it over 1.
Put it over 1, huh? Put it over 1, and then what? 2 goes into 16 8 times, right? Cross cancel. You put the whole number over 1, because whole numbers are really over 1. They're really in the top, aren't they? We good there? 2 goes into 8, so 2 is 16 minus 1/8. Which is the answer, isn't it? Yeah. How we doing? You guys are awfully quiet today. Are you tired? Is it the end of semester tiredness? This is great. As I look around, what I mean is, there's more than half of you still here. This isn't normal. I'm glad. Normally, first day, it's all packed and people trying to add. And I always think, that last day, how many will really be here on the last day? This is great. What is this, 80% of you? That is great. Like I said, I'm up for a big raise, I'm sure. I just got to let the dean know.
Glad we could be of assistance.
Yes, thanks for helping. Yeah. No, it's great. I'm glad so many of you are successful. You're all passing, right? I don't know off the top of my head where all your grades are, but hopefully great many of you are. All right, minus 1/8. We good on that? That makes sense? Any questions I can answer? Yeah, usually at the last day, it's like no more than half of the class is left standing. So this is much better than I'm used to. This is like summer school or something, which is... So number 9. Things are going to change on number 9. Dot.
So S is in.
Yeah, so how do we know it's going to be the other form, the S sub n formula now? Right at the top, instead of the Instead of the A sub n, it's going to be the one in the middle, the S sub n. How do we know? Why is it for sure the S sub n? Because they're summing them, they're adding them, huh? Remember, S stands for sum. Like that. All right, see if you can plug everything into that formula. All right, how we doing? What's A1?
1/2.
First term, huh? A1 always means first term. A sub 1, so that's the half. Really good. Excuse me. 1 minus, 1 minus. Now, what's the R?
The ratios.
That's tricky. What's the R? R is what it's being multiplied by every time, right?
Like second power.
What's it being multiplied by? So if you take a half, what do you got to do to a half to make it a half squared?
Times another half.
Times another half. And what do you got to do to a half squared to make it a half to the third? Times another half. It's multiplying by another half each time, isn't it? Yeah, dramatic music at that point. It's important point. Right? Is that making sense? It's multiplying by another half every time? You don't seem very happy with that. Let me give you a formula to help in case it's ever unclear. R stands for ratio. If I take 2 and I say, hey, 6, 18, da-da-da, what's being multiplied by every time? Let me just give you an example. What's being multiplied by every time there? Times 3, right? And how you can tell that is you take 6 divided by 2, what do you get? 3. So if you divide, like the second term over the first term, you'll get what's being multiplied. That's how you find what was multiplied, you divide them. So that's what you do. You take the second term over the first term. If you're ever unsure, if you're ever looking at a bunch of numbers like, I can't tell what the R is, well then just take the second term over the first, like 6 over 2 would tell you the 3 right away, wouldn't it? In this little problem. Well, in the same thing in our little problem, if we take the half squared, second term, right, over the first term, which is just a single half, see what we'll get? We'll get a half times a half over a half, cancel a half. So the R is a half. It's being multiplied by another half every time. Is that making more sense now? So if you're ever unsure what the R, and this will become really important because they're going to get kind of weird in a minute, you know. It'll be hard to tell just by looking. So you're going to really want to use this. For sure, write this down. This is very, very helpful. So R is always second term over the first term. That's why it stands for ratio. That's why it's R. It's ratio. Ratio is a fraction, right? Second term over first term. And that'll tell you what was multiplied. When you divide two things, you find out what was multiplied, right? Okay, so anyway, back to the problem. The R is the half, so I put the half to the end over the half. I'm kind of running out of room here. So right now I've got this. You tracking with me? Wait, let me bring it down here. These aren't easy. This is where they get a little bit ugly. So far, so good? I would just start using decimals. They're just easier. Just make both of what's half into a decimal? 0.5, right? I would just make both those halves 0.5. That'd just be easier. Make that a 0.5, that a 0.5. That good? A little better? If you're really good with a calculator, you could just type all that in. I'm going to show you, probably for most of you, 1 or 2 more steps by hand will make the calculator work easier. Let me show you. Here's what I would do by hand. I would say, okay, 1 minus 0.5 to the end. I would say, look, what is this right here? What is $1 take away 50 cents? Well, 50 cents, right? Good so far? Okay, so what? Well, then, what you could do is you could multiply. It's a fraction, right? When you can just multiply the bottoms together and the tops. Fraction, right? Top times top, bottom times bottom. So 1 times the top, that's not going to change the top at all. Over, what's 2 times 0.5? What's 50 cents twice? $1. Right? See how I simplified that? Now type, and the 1 on the bottom you can ignore, right? We always ignore 1s on the bottom, doesn't change anything. So now just type, oh, we don't know in yet. Yeah, we got no in. Hold on. We're almost there. Can't type it in right now. It's got an in. But everybody good so far? How are we doing? Have I lost you in my steps? So I'm taking that S sub n formula, put in A1's a half, first term. The R I found, R is second term over first term. That was a half squared over a half, half, cancel, it's just half. So put in half for the R. Thought that was ugly, made those 0.5s. Then I thought, okay, let's clean it up. $1 minus 50 cents, I just made it 50 cents on the bottom. Thought I multiplied top times top, that didn't do anything. 1 times it didn't change the top at all. The bottom, 2 times 50 cents twice, made $1. Okay, now let's put in the in. What is in? What is in all these things? Number of terms, huh? How many terms? This is the first one, second one, third one, all the way to the 8th one, huh? There's 8 of them, right? See the power of 8? There's 8 of them. So n is 8, isn't it? So put in right there, 8. Bless you. We good so far? Now hit the buttons on your calculator. I will too. And that 1 on the bottom, ignore it. Dividing by 1 does nothing. Let's get rid of that. So we've almost got an answer. So let's see. 1 minus 0.5 to the 8th. I'm getting 0.99609375. Is that what it says in the back? Oh, it shows a big fraction. Whatever, same thing. Did y'all get that? We good? You guys need any help on the calculator? You know how to do the power button? That's the up arrow or the X to the Y or Y to the X. Different calculators have different buttons for power. So 1 minus 0.5 to the power of up arrow or X to the Y, 8 equals. On that. Alex?
So for some reason my brain's just farting right now. Is there, since, is that going to stay a minus? That minus in front of that if I'm doing...
Yeah, good question. No, I'm with you. Good question. Yeah, this, because you're wondering, well, 8 negatives is positive, right?
Yeah.
Good question, but this 8 does not talk to that negative because he's not in the parentheses.
Okay.
He only talks to things in the parentheses. Good question. So yeah, the minus stays minus. Were you guys able to get that answer? Is that working out? Yeah.
How did the 0.5 become a 1 in the next area?
How did it become a 1? What do you mean it?
0.5 equals 1/2.
Oh, right here. These guys multiplied. 2 times 50 cents? What's 50 cents twice? $1, right? 2 times 50 cents made $1. 1. So I did bottom times bottom, right? These guys, see me circling them? These guys multiplied. I just did top times top and bottom times bottom. Yeah, good question. Other questions on that one? Now, how are you going to do it on the final? Because the final, the answer on the back, you look at the back here, the answers are all here on page 2. It says 255 over 256. And we've got this 0.996 thing. How are you going to know if that's the right answer or not? Your calculator. Oh yeah, the nice ones will switch back and forth. Even if you don't have one of those nice ones, just take 255 divided by 255. You just check the answers. If they're all fractions, doesn't matter. You can make everything into decimals, right? Just take the answers and go 255 divided by 256. It'll come out that same decimal, and you grab it. Make sense? So you don't need to go to fractions. You can just make all the fraction answers decimals real quick. Boom, boom, boom. That good? So you can just work in decimals. Questions on that one? All right, that was a harder one. Let's keep going. Number 10. 1/3 plus 2/3 plus 2 squared times 3 plus 2 cubed over 3 plus dot 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 plus 2 to the 10th over 3. All right, which formula are we going to use? A sub n or S sub n? They're being added. You guys tracking with me on the final? Anything being added is an S formula, isn't it? S formula, S sub n. A1, 1 minus r to the n over 1 minus r. See what you can do. Feel free to compare with those around you.
Last semester, yeah. Three A's.
Yeah. You can do 1A?
Yeah, I'm gonna do one A next semester.
Next semester, okay.
Yeah, I have to do this.
Yeah. Oh, that's right, this is prerequisite.
Yeah, well, I don't think I'm gonna have very much trouble. Like, I came back and I got a really high C last semester in prep class.
Okay.
And my cousin who's going to UC Irvine, she said, you know what, I did the same thing in my prep class. I got a low score, but the first chemistry class, yeah, I did just fine, got an A, so
Good.
I don't think I'm gonna have too much trouble. And I only got 3 classes next semester too. I got Trig, C18, 15, and then,
Chem 1A.
yeah.
Chem 1A is 5 units lab and everything, so it's probably a good load.
Well, plus I'm doing ETC.
Oh, yeah.
Either
Good.
here.
The higher John, huh?
Poli-sci.
All right. So A1 is 1/3, right? We good? A1's just first term. Good. 1 minus 1 is, now what's R?
2.
Good. 2. Right? 2 ways you can get it. You can get it by observation, if you're a real good observer. What do you got to do to 1/3 to make it 2/3? Excuse me. You got to multiply the top by 2.
The second one.
What do you got to do to 2/3 to make it 2 squared? Another 2 on the top, huh? They're just multiplying by another 2 on the top, aren't they? Notice the 3 on the bottom is not a change agent. It's not what's making things change. It's just always there. What's changing from term to term is it's getting an extra 2 on the top, isn't it? But anyway, you don't have to do all that observation. You can just use the formula I told you. How do you find R by formula? Second term over first term. R is always second term over first term. So second term, 2/3 over first term, 1/3. You guys tracking? Am I going too fast? Is that good? That's always how you find R. Second over, it's the ratio, right? R stands for ratio. Second term over first. And you know what you do? What do you do when you got a fraction on the bottom of a fraction like that? Grab the 1 on the bottom and you flip it up. Remember that? Like a high diver upside down. I always picture running my recording backwards when they do the high dives in the Olympics. So the divers will flip out of the water like a fish. That's what it always reminds me of. Maybe I just have a strange mind. 3 over 1. Flips up like that. Right? It flips upside down. Right? 3's will cancel. 2 over 1, 2. R is 2.
So 1 minus 2 to the end.
So this is 2 to the end. So bring it over, right? It's 2. The R is 2. Are we good so far? We're not done yet. But we good to this point? We got to keep that thing moving. The bottom, what's 1 minus 2? Negative 1. Good so far. And then what do we always do at this point? We multiply top times top and bottom times bottom. So 3 times negative 1, that's negative 3 on the bottom. The top, 1 times the thing doesn't change it at all. We good to there? How we doing? Just making this what I just did on that step. I just did top times top and bottom times bottom, right? 3 times negative 1, right? 2 fractions multiplying is do top times top, bottom times bottom. Now, last step. What's your n? You got to plug in the n there. N's the 10, huh? No, n means number of terms. Always means number of terms. It's the 10. That's your n. So put it in right there. And then Now, can you type that into your calculator and get an answer? 2 to the 10th will be 1,024. Subtract that, 1,023 over negative 3. And then divide that. I think it goes in. 333 and 8. 341. 41? Is that right? 340. Is that the answer on 10?
Yeah, 341.
Well, but on the answers it's.
Yeah, I'm concerned about that myself. Oh. Yeah. Yeah, this is a trick one. I didn't notice the trick. It tricked me too. N's not 10. I was dead wrong. I say a lot of things that aren't true. I just try to keep them to a minimum best I can. That's one of ones.
It's 12.
No? Okay. So look at in. Right here, this is first power. First power, second power, third power, 10th power. This is 10 terms right here, isn't it?
Oh, it's 11.
So there's 11 total. Does everybody see that? They're tricking us. You can't just always look at that last number. How do you know when you can or can't? Well, you got to look at the beginning, see how it starts off. Do you see the trickery they did to us? See, the power starts with 1 after the 1/3, huh? See that? That was dirty, rotten problem.
It's 11?
So n's 11. See how there's 11 total terms actually up there? Do you see that? See, 1 through 10 is 10 terms, and then you got the 1/3 in the front also. So there's 11 terms. So go back,
So
make this
20,
11.
Number 3?
I don't know what it is. I mean, it's probably what I'm sure it's what the answer key says. So it's 1 minus 2,048 over negative 3 minus 2047 over minus 3. Is that what it is? The two negatives cancel.
Yes, I get it.
There we go.
How is it different than number 9?
Yeah, let's go. Let's compare number 9. See how number 9 it started with a 1 power right there? So that's only 8 terms. There wasn't something before the 1 power. Right? Making sense? Everybody see the difference? See how number 9? You could put a 1 power in there and just count it off. 1, 2, 3, all the way to 8, huh? There's only 8 of them. But in number 10, this is 10 of them, and there's 1 more. It's trickery, isn't it? Gotta be careful. All right, we okay with that? Tricked me too. All right, let's try number 11, since these are tricky. 1 minus 2 plus 2 squared minus 2 cubed plus dot 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 all the way to plus 2 to the 10th.
Are you going to take us on the test?
Probably.
Worst case scenario.
At least we're not lying about
All
Yes,
right.
he is.
Try that one.
Probably. He said.
Well, this one is just like the one above it with no fraction.
What's that? All right, same formula, S sub n. So find your R, right? Remember R is second term over the first term. What's R?
-2.
-2. Good. Did y'all get that? R is actually -2, isn't it? Second term is -2 over first term is 1. -2 over 1 is -2. So your R is -2. You got to take the sign with it. Good job. R is -2.
Oh, yeah.
So R is -2.
Yeah.
The formula says 1 minus a is 2 and 1 plus 2.
Yes. On the bottom.
On the top.
But on the top, you got powers first. So you can't cancel those negatives until you've dealt with the power on the top. So the S sub n is A1, 1 minus R to the n. I didn't tell you where this formula came from. Who came up with this formula?
Same guy.
It was Gauss the next year, 5th grade. No, I'm kidding. I have no idea who came up with it. I have no idea. All right. A1. What's A1? First term's 1. Times 1 minus R. What's R? Well, we talked about that. It's negative 2, huh? R is second term over first term, which is negative 2 over 1. Oh, not over negative 1. What am I doing? And so it's just negative 2. Now watch out. You gotta be a little careful with your signs. Watch the ball closely. Right? Now, can you cancel double negatives? Yes, if there's no power on it. Powers are first. Remember the order of operation? Powers. Please excuse my dear Aunt Sally. So don't be canceling those two negatives on the top. You got to do the power thing. On the bottom, sure, go ahead. It's going to be 1 plus 2, going to be 3. But on the top, you better leave it because there's a power on that negative 2, and powers come first. Don't cancel those negatives on the top until you've resolved the power issue on the top. Does that make sense? That's buyer beware. That's solver beware right there. Easy mistake to make. What's in? Oh, that's the big question. So now we're a little bit leery on it. Everybody think about it for a minute. Suppose your life depends upon it. You get one shot. What is the value of in? For all the money, the final exam will be one question like this, and it'll say, what is in? Is it 10 or is it 11?
11.
The whole thing. Can everybody tell? It is 11, isn't it? Because 1 starts right here. This is 2 to the 1. So right here is 10 terms, and then this is another one. So 11 terms. N is 11. Good? So put 11 in here. Good? Okay. So let's wrap this thing up then. Bring this down to here. So we don't need that 1 in the front. It's not doing anything. Minus 2. The bottom is 1 plus 2, isn't it? So 1 minus, and then what's minus 11 is minus 2,048, isn't it? It's going to be negative because an odd number of negative signs is negative, right? Just take 2 to the 11th and you can't, well, you can just do minus 2. So minus 2,048, this is 3. So this is 1 plus 2,048 over 3. This is 2,049 over 3. And that's 683.
All right.
Boom. You getting the hang of these?
Is that an 8 or is that an infinity?
Eight.
Okay.
You good? Questions I can answer? All right, can we move on? Let's try number 12. Can I move the screen? You all good? All right, number 12. Number 12 has got, what's that big symbol again?
It's an S.
It's a big Greek S. Sigma, technically. Big Greek S. And what do you think? Which formula do you think I'm going to use when I've got a big Greek S?
Some.
I'm going to use the S sub n formula, aren't I? S sub n is A1, 1 minus R to the n over 1 minus R. Hey, how are you going to know? We did some big Greek S's Monday, and we used the other. That was the other handout. On the final, they're all mixed up. How are you going to know whether to use the S sub n from today, the geometric, or the one we used Monday, For arithmetic, how are you going to look at this and know that's geometric? That's something more powerful. What's powerful about that? N has climbed into power. Remember all my talk about Hitler and Stalin and climbing into power and all that? Right? Letters in the power zone are a powerful thing. It's geometric. It's geometric, not simple arithmetic. It's higher level. So when you see the letter climbed into power, you know, okay, it's the more powerful one. Okay, here we go. We need a sub 1. How do we get a sub 1?
Well, it's
We got to crank out a couple terms from this sequence. Do you know what I mean? This is a sequence where you can crank a couple terms. It says, use this formula, let n be 1, let n be 2, let n be 3, I'm not going to do them all the way to n8. That's what it's saying, right? And then add them up. You okay with the language? That's what it's saying. It's saying plug in 1, so that'd be 2/3 to the 1. Plug in 2, 2/3 to the 2, and then add these up. 2/3 to the 3, add it up 2/3 to the 8. That's what it's really saying, isn't it? You okay? It's saying the formula 2/3 to the n, let n start at 1 and end at 8. That's what that formula means. And S them, sum them. It's a Greek S. Sum them, add them all up. Plug in 1, 2, 3, 4, 5, 6, 7, 8, and add them all up. Now, I'm not going to do all that, but that helps me know what A1 is. What's A1?
2/3.
2/3, huh? So A1 is 2/3 times 1 minus 1 minus. Now, how am I going to get R? What is R? R, what's the formula I gave you for R?
It's +1.
R is always second term over first term, right? Second term is this one, 2/3 squared, over first term, which is just
4/6.
a single 2/3. We're multiplying, not adding. So this is 2/3 times 2/3 over 2/3. Bye-bye. 2/3. R's 2/3 also. Right? You track with all that? We good? So R is 2/3. So bring that up here. 2/3 to the n over 2/3. That's ugly. So we're going to have to clean that up a little bit. It's not nice. Yeah, what kind of answer they're going to give me? This is really getting ugly. All right. Yeah. You can do the rest. Right, Renee?
Yeah, no.
All right.
That was
Yeah, the answer's got the ... It's all there in the answer key, see?
wow.
Yeah, it's a little messy. Okay, let's keep going. So can I go to fresh screen? You guys got that down? So it's 2/3 times 1 minus 2/3 to the n. Oops. Oh, it's getting messy. I'm scribbling. Okay, what's n? What's the number of terms here?
I don't even know. 8.
8 of them, right?
Yeah.
N equals 1, N equals 2, N equals 3, all the way to 8. The end is 8. So there's 8 total terms here. We good with that? So let's put in an 8 right here. 8, 2/3 to the 8. Good so far? Now, what's this? I want to do this, well, what's trying to think what would be the easiest way to help you with this. Probably, okay, at this point we let the top multiply the top and the bottom multiply the bottom, right? When two fractions are multiplying, top times top, bottom times bottom, right? So what do you get? 2 times 1 minus 2/3 to the 8. The bottom, the 3 times 1 minus 2/3, right? Everybody good so far? Just multiplying top times top and bottom times bottom. Good. So let this 2 go in. Boom, boom. 2 times 1 is 2. It will be.
Great.
2 times 2/3 to the 8. And the bottom, 3 times boom, boom. 3 times 1 and 3 times 2/3. This isn't beginning algebra anymore, is this? You guys are in advanced algebra. This is basically, it's not even intermediate anymore. This is like advanced algebra. I do this in pre-calc. These exact sequences and series, exactly what we're doing in these two. This is a pre-calculus topic this semester.
I'm gonna fall off this.
These will cancel because he's over 1. Oh. 2 minus 2 times 2/3 to the 8 over 3 minus 2. See that on the bottom? We're so close.
Oh yeah, they do cancel.
See what happened there? 3 times 1 just made 3. And this just made 2. And so what do we have? 2 minus 2 times 2/3 to the 8 over 1. Now bottom is just 1. We don't need that.
Minus 2, oh good.
So now, type it into your calculator. I mean, you could have typed it in at any stage previously. If you're real good, your calculator's real nice, user-friendly, you could have just typed all, come on, this thing is bugging me. You could have typed all this in and forget all the by-hand simplification. You don't have to do all this by-hand simplification if your calculator's real user-friendly. You could type it in at any stage. I'm just trying to make it as easy as possible for you. This would be easier to type in to your calculator probably. So I'm going to type that into my calculator. But you do got to do parentheses. You got to use the parentheses. I'm getting 1.92. Why is it scribbling up? 0.921963. You guys getting that? Good deal. Yeah, you could try, guys and gals. You could just try. If you could type all that in up there, then you don't need to do all these by hand steps. You know that might be kind of hard. I'm only doing that to make the calculator stuff easier. But if you're good with the calculator, even way back there, you know, at any point, just type it all in. If you're good, you gotta be good though. You gotta put parentheses around numerators and denominators. Keep it all separate.
I'm getting the same answer.
So there we go. I'm fine with decimal answers on this thing. You know, they gave some fraction answer. Who cares? Final exam, you can match it up.
They
Calculator.
gave you gave like a series of like 4.
Yeah. We have a bunch of them. Let's just stick with the decimal. Good?
But why? Why is there so many answers?
They're all the same thing. Just simplifying. All right, these, I don't want to spend forever on this stuff. Maybe we should do one more of these sigma ones. These, like 14 maybe?
Okay, I have a question before you go on.
Yeah.
Back in the last problem, number
12?
one before that.
11?
One where we had to figure out when it was like either 10 or 11.
Yeah, this one, number 11.
Yeah. How do you know when?
Yeah, you got to find where the first power is. It's all about finding where the first power is. So look at what they gave me. It's all kind of scribbled up now. But here's what they gave me at first, right? Look at the countdown. 10, here's the 4, 4, 3, 2. So this guy's got to be the 1. So that means from here to here is 10. And this is extra. So there must be 11 terms. Did that make sense? Everybody see how to know how many terms? Find where the 1 is, the 1 power. I'm talking about powers. Find out where the 1 power is. That's That'll let you see, oh, there's from there to the end is 10 terms, and there's even one before that. So there must be 11 total different terms there.
So, the 1 is actually the first.
I'm just saying the 1's a counter.
Okay.
Does that make sense? It'd be kind of like if I said, it'd be kind of like this. What if I said, hey, I'm going to give you a bunch of numbers. Ready? 0, 1, 2, 3, 4. Well, you know 1 to 4 is 4 numbers, and there's an extra one, so there must be 5 total numbers up there, right? That's all I'm saying. Find where the 1 is, you know that, and then if there's an extra, add 1. All right. Come talk to me. Well, if that's still confusing, try this one, number 14.
It's like asking how many numbers are there 0 to 10. When people say 10,
Yeah, they do that all the time, don't they?
it's 11.
Or you know the same trick. People will say, I see this all the time. People say, I was reading the book. I read pages 72 to 76. I read 4 pages.
Yeah.
That's not 4 pages.
No, it's not.
Just list it out. 72, 73, 74, 75, 76.
Yeah,
They just think they can subtract.
yeah, no.
You guys subtract and add 1.
Yeah, it doesn't work like that, yeah,
Yeah.
exactly. Yeah, that's the way you count hours too.
Yeah, any gap between 2 things. Yeah. All right, so use the S sub n formula. A1, 1 minus r to the n over 1 minus r. Your favorite math formula, maybe?
I like these formulas, I'm not opposed to them.
You'll see them again if you go up the line in math. Pre-calculus, 2 steps up the line, trig and then pre-calc.
Yep, next fall.
Right, keep all on track.
Yeah, you're gonna teach pre-calc next fall, right?
The schedule's not out, I have no idea.
You always tell me that, every time I ask you if you're teaching something. you never-
Sound like my daughters, that's what they always said. They said, Dad, why don't you ever teach the classes we need to take?
I know,
Well,
right?
let's make the schedule. So you're going to have to list a couple of those terms there because you got to find A1 and got to find R. I'm growing a little weary of these things, so I'm going to whip this one out. These are just tedious, aren't they? They're just messy. All right. So remember, you're supposed to start and n equals 1, and do 2, and da-da-da-da, all the way to n equals 10, right? So plug in 1. What are you going to get? 2 times 3 to the 1 minus 1. Is that good?
1 minus 1 is 0.
Yep. 2 times 3 to the 0. Yeah, I'm going to run out of room, aren't I? Here, move this out of the way. You guys tracking with me? I'm plugging into this formula. Bless you. N is 1. So I get 2 times 3 to the 1 minus 1 power. 2 times 3 to the 0. Anything to the 0 power is? 1. 2 times 1 is 2. Good for the first term. The first term's a 2. A1's a 2. Let's try plugging in 2 now. 2 times 3 to the 2 minus 1, which is 2 times 3 to the 1, which is 6.
It was 2 times 3. Oh, no.
All's well? Everybody see that? How that happened? First term's a 2. Second term's a 6.
Can't we fast forward to the n equals 10?
I'm not even going to do that one. So now I just need R, which is second term, over first term. 6 over 2.
3.
R is 3. So R is 3. Okay, now we're ready to crank out our favorite formula. S sub n is A1, 1 minus r to the n, over 1 minus r. A1, 2, R is 3. Good so far? R is 3, A1's 2. What's in? It's gotta be 10, right? Starts at 1, ends at 10. You start at 1, end at 10, you did 10. Right? So the end's 10. Good. I feel like I'm dragging y'all through this, or I'm wanting you to stand up and run with me. I feel like I'm dragging you. How are we doing? Are you running with the math or being dragged through the math? Okay, so use your calculator. 3 to the 10th is something whopping big. Excuse me. 59,049 over -2. And so that's minus 59,048 over -2. I'm betting the answer is 59,048.
It is.
Somewhere on that page. Yep, 14, there it is. Good. Good. All right, I'm going to move on. Any questions on this one? Question?
Is this like the introduction to pre-calculus? No.
All right, so number 15. We've only got a few more in this handout. We've basically done almost all your homework. This last section, what do you want? Do you want an easier section or a harder section? I'm just joking. I always say that when I have an easier section. It's easier. This last section will be easier. 1 plus 2/3 plus 4/9 plus dot, dot, dot.
There's
What's
no-
with the dot, dot, dot?
It's infinite.
That means infinite. That goes on forever. We're adding up things forever. Do you get that? We're adding up things forever. If you add up things forever, positive numbers forever, what are you going to get?
Infinity.
Aren't you going to get infinite?
Infinity.
Do you guys see the pattern? I mean, what would be the next one? What's happening from term to term now? Let's do a couple more terms. See if you get in the pattern. What's being done to the number on the top? What's being done to the number on the bottom? It's timesing the top by 2 and the bottom by 3, 2/3, huh? So next one would be 8 and 27, etc. It's multiplying by 2/3 every time. Everybody see that? Yeah.
How do you know it's not being squared?
How do I know it's not being squared? Good question. Because that wouldn't work to go from here to here. Square 1, you wouldn't get 2/3. Good question. Good? Everybody see that? So it's multiplying by 2/3 every time, isn't it? Top times 2, bottom by 3. Okay, no, but I want to bring back to you the basic question. We're adding up positive numbers. They're never going to become negative. They're always positive numbers, aren't they? And the difference between, what is the difference between this question, all these questions, 15 through 22, this last section, it says in problem 15 to 22, find the sum of the infinite geometric series. The dot, dot, dot. It's the fact that these go on forever. They don't stop after, what is in? How many terms? Infinite. N's not 5 terms, 10 terms, 20 terms, 100 terms, 1,000 terms, 1,000,000 terms, 1,000,000,000,000 terms. It's more than that. It's infinite terms. So we're adding up an infinite amount of terms, not a finite number of terms. That's what's different. That's what's changed. So how can you add up an infinite amount of positive things? What are you going to get? If you add up an infinite amount of positive things, what are you going to get? Aren't you going to get infinity? If you add up an infinite amount of positive things? Right? Imagine taking some trash. Did I already do this analogy with you guys? What if I said I'm going to throw some trash in the trash can? Trash. More trash. More trash. More trash. I'm going to do it forever. How much trash?
An infinite amount of trash?
Infinite, right? I mean, it's going to overflow, right? If you do it forever, right? If they're all positive, I mean, they're all more and more. They're building up. It's getting bigger, right? All the way through. You with me? How are we doing? I'm trying to get you to think deeply here on the last day. Am I reaching you, or is the Charlie Brown teacher taking over? One, trash, one, trash, infinite, one.
Think about hotels with an infinite amount of rooms and an infinite amount of people.
I just wanna know why the answer is
I'm
three.
fine with the answer.
I do too.
Why is it three?
I want you to think about the infinite because it's very interesting. Think with me again. If you're adding positive things, isn't it getting bigger? As you add more and more, if I throw more and more, it's getting bigger. And you're doing it forever. It's getting bigger forever. So it's going to be infinite. Isn't the answer just infinity? No, the answer is 3. It's not going to go to infinity. You can add up positive amounts or trash in the trash can forever and not have it go to infinity. Doesn't that seem strange? How can you add up things forever? Positive things, negative, obviously, that'd be dumb. Add up positive things forever and have it not be infinity. Well, I've already shown you, I think I have, haven't I? What is 0.9 bar? Didn't I do that a while ago? Didn't I? I think it was one of my other classes. What is 0.9 bar?
9 for infinity.
Yeah, right. You guys know what the bar means on a decimal? Repeats. So it's just 9s forever, right? 0.9s forever. What's that equal to? Is that equal to 1?
No. It will never be 1.
It'll never be 1?
Never.
Is it close to 1? The 9s go on forever. Is it close to 1? 0.9's forever?
Yeah.
So I didn't do this. You guys are giving me the look like this has not been done. All right, let's talk about it. 0.9's forever. Is it 1 or close to 1? Is it exactly 1 or is it close to 1? Just so close, huh? How close?
Infinitely close. So close.
Infinitely close.
It is infinitely close to 1. It will never be 1, but it's infinitely close.
It'll never be 1. Is it not 1?
No, it's not 1.
Are you sure?
I couldn't tell you.
Are you sure?
I'm pretty sure. I don't know.
Okay. So let me ask you this. I'm going to tell you it is 1. And then I'm going to prove it.
Because we round or what?
No rounding. No, because if you rounded, that would just be close.
I don't know.
I'm saying it's not just close to 1. It is 1. It's another way to write 1.
Is it like the gas when it's like 9 of 10 cents or something?
No, that's just a way for the gas company to try to fool you somehow. No, this really is 1. Now, I'll prove it to you in a minute. And I'm not pulling your leg. It's a weird result of infinity. Infinity is weird. So my point is this number is precisely 1. It's exactly 1. It's not different from 1 in the slightest. It's exactly 1.0. 0.9s forever is exactly equal to 1.0 without any difference at all. It's another way of writing 1.0. Now, really? If I was you, I'd be like, no way, Mr. Heron. The calculator does it. Let me prove it to you this way. Proof in something you already know. What is 1/3 equal to? In decimals. If you go 1 divided by 3 calculator.
3.
What is 1/3? Anybody know that one already?
0.333.
0.3 is forever, right? You with me? Everybody knows that, right? 1 divided by 3 is 0.3, and it's not just 0.3s for a while, it's 0.3s forever. I got to get the forever thing in there, right? Okay, so right, you know that. That's not a surprise to you. That's what a proof is. You take somebody from something they already know is true, you do steps which they agree are true, and you arrive where you want to arrive. So 1/3 equals 0.3s forever. That you know. If I take that little truth, that little equality, and I multiply, or if two things are equal, and you treat them the same, they'll be equal afterwards, right? These two things are equal. Exactly equal, not just close. Exactly. 1/3 is exactly 0.3s forever. Calculator will tell you, right? So if I multiply both sides by 3, if they were equal before, they're still going to be equal because now they're just 3 times as big. They were both the same, now they're 3 times as big. What's the right side? How do you multiply 0.3s forever times 3? That's not a trick question, is it? 0.3s forever times 3. They just become 0.9s forever, right?
Alright.
With me? Wouldn't that just be 0.9s forever? All those 3s, it would just boom, 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 right? Just multiply them all. Right? And what's 3 times 1/3?
1.
What's that? I got 1/3 of a pie 3 times. I ate 1/3 of the pie 3 different times. Yeah, or it's 1, right? 1/3, 1/3, 1/3. It's 3/3. It's 1. Proven.
Yeah.
See how it's true? It's really true. It's actually true. So now what in the world does that have to do with this? Well, excuse me again. Think about what 0.9s forever is. Isn't it 0.9 plus 0.09 plus 0.009 plus 0.0009, etc.?
Yeah.
Isn't that a way you could write 0.9s forever, right? A single 9, a 9 2 places back, a 9 3 places back, a 9 4 places back, da-da-da-da-da. Aren't I adding up positive numbers forever? And yet you know it's not even, doesn't even go over 1. So of course we can add up positive things forever and not have it go to infinity. We already knew that if we thought carefully about 0.9s forever. It's a finite sum of 1. Do you see that? Are you guys up for all these deep thoughts on the last day of algebra class? So 0.9s forever is 1. It's exactly 1. Not just close, but right on the money.
So what point does it diverge into 1?
How about this? Let me. Yeah, because it seems like no, it's close, but it's not 1 right on the money. Well, this first off proves it is 1 right on the money, right? I multiplied both sides by 3, and this is 0.9s forever, and this is 1 right on the money, and they are equal.
Yeah, but we're disregarding the fact that...
Okay, well, let me give you one more proof. I don't want to use too much time. If you're still like, no way, Mr. Heron, I saw your little trick thing. I don't know what you did there. Some kind of trickery. I don't know, but it's not the same. Okay. If you say it's not the same, if 1.01, is not the same as 0.9s forever, then they must be different. Right, okay. And if two things are different, when you subtract them, well, how about this? If two things are the same and you subtract them, what do you get? If two numbers are really, truly the same,
0.
and you subtract them, what do you get? 0, right? If they're really the same. So if these numbers are really different, here's a second way of proving it. If these numbers are really different, I better subtract them and I better get something. I better get a difference, right? If they're really different. And I won't, because they're not. Here we go. Now, how do you do that? How do you take 1.0 and subtract 9s forever? I mean, where do you even start? The 9s go forever. Where's the right side? You see the problem? Well, we start on the right side when we subtract. Where is the right side? It goes forever. Right, that's part of the problem. So let's do this. Let's just look for a pattern. Let's just subtract a single 0.9. I know that's not the right number, but let's just start there. If it was really just a single 9, 0.9, we would subtract and we'd get 0.1, huh? That would be the difference if there was only one 9. But there's not only one 9. There's infinite 9s. Oh, okay. What if there was 2 9s? What would we get if there was just 2 9s? What would be the difference between 1 and you'd get 0.01. That would be the difference between 1 and 2 9s. But there's not 2 9s. The 9s go forever. Okay. What if there were 3 9s? Well, you'd get 001. Right. Okay, but there's not 3 9s. The 9s go forever. Right. Okay, what if there's 4 9s? Well, you'd get 0001 if there were 4 9s. But there's not 4 9s. The 9s go forever. Right. So you got the pattern, right? So the 9s go forever, which means the zeros go forever, and then finally comes the 1. Right? You agree with me? right? That's how the subtraction would actually work. So when does that 1 come? After what? After how many zeros?
Infinity.
After infinite zeros, right? Because there's infinite 9s here. After infinite, how long does it take you to write infinite zeros?
Forever.
Forever.
It's exactly.
So if I said that 1, when is he coming? After forever.
So he never comes.
If I said, I'm feeling generous, I'm going to give you all $20, and I'm going to give it to you after forever. When am I giving you the $20? After forever is another way of saying
That's kind of perfect.
never. So that 1 comes after forever, right? After all the 9s are done, then the 1 comes. After forever, he comes never. So he doesn't ever come, and the difference is
0.
0. And those numbers are the same, not just close. They are exactly the same. I'm not fooling you. You can type into Google. It's the truth.
That was good.
0.9 bar is 1. All right. Having all said, so that my point is the infinite does some slippery things. That's what calculus is all about. I'm trying to encourage you to go on towards calculus. Calculus deals with the infinite and how funny things happen that you might not expect in the infinite. All right. With all that build up, Kara just wants the formula. Kara's just thinking, come on, Heron, just give me the formula. All right. I'll just give you the formula now. No more Twilight Zone mathematics. Here we go. The formula. It's on your page. I don't need to give it to you. It's right there. See it? See the one at the third one? S sub infinity. That's got to be the one, right? We're doing infinite terms. It's got an S sum. We're adding up infinite terms. Notice it's an easier formula. This is why I told you it's easier. A1 over 1 minus R. Here we go. So what's A1? A1's first term, 1. Okay, what's R? Remember how we always find R? Second term over first term is going to be 2/3. 2/3 over 1 is just 2/3, huh? Good to there? By the way, we could do this with the point. We could prove the 0.9 bar thing this way. You want a third proof? We could also do that. I just like to prove it to you from so many angles. All right. Now, what is the bottom? What is 1 minus 2/3?
That's 1/3.
Good. Is everybody okay with just jumping right to 1/3 without playing games? Right? That's 1/3, right? Because you have a whole pie. You take away 2/3 of a pie, you got 1/3 of a pie. Right? And then what do you do with a fraction on the bottom of a fraction? It flips it up. Oh, maybe have I not explained that before? Fraction on the bottom, fraction flips up. Do you know that? Because it's 1 divided by 1/3, right? 1 over 1/3 means 1 divided by 1/3. And remember when you, to the right of a divide, you flip it and change the times? Do you remember that? So that's what I'm saying. So it ends up becoming 1 times 3 over 1. It flips upside down. Have you guys seen that before? I'm just assuming. Maybe I shouldn't be assuming. Whenever you have a fraction on the bottom of a fraction, this is important. That's the high diver upside down thing I was talking about. It flips up. It goes up to the top and becomes 3 over 1 up to the top. Why does it do that? Because it's 1 divided by 1/3. And you remember when you write divide sideways, you flip the 1 on the right? That's all I'm doing. So it's 1 times 3 over 1, which is 3. There's why it's 3, Kara. Is that good? That making sense? Now, having said that, that formula is not always true. Did you notice there's a condition? Oh, I didn't. Oh, yeah, I did right. So up by the formula it says only when R is between -1 and +1. Only. This formula is only allowed to be used, will only give you a true answer. I mean, you can use it whenever you want, but you'll get junk out of it if you use it wrongly. You're only getting the truth out of it if you're plugging in an R value between -1 and +1. What's my R? 2/3. Is that between -1 and +1?
Yeah.
Absolutely. If you did a number line, here's -1, here's +1, here's 0, 2/3 would be about right there. Yeah. 2/3 is between -1 and +1. So you always got to check that. If the R is not, then you say diverges. If R is not between -1 and +1, then we just say the series diverges, which means it takes off to infinity. You can go to infinity if you add up a bunch of numbers that are too big. In other words, r has got to be a fraction. Make sure you let Ajane know this later. R's got to be a fraction. We good? All right, on to number 16 we go. All right, 4, 2, 1, dot, dot, dot. Try number 16. How will you know you're supposed to use the s of infinity formula?
Because the end dots are.
The dot, dot, dot. Yeah, it's going forever.
Ooh. Yeah, no, because R is greater than 1.
What's r? Second term over first term.
Oh,
2 over 4, a half.
I'm good, okay.
We good? R is a half. Is that r between -1 and +1? Yeah, basically r's got to be a fraction, basically. So that make a proper fraction, where the bottom's bigger than the top. So that's okay. Use the formula. S sub infinity, a1 over 1 minus r. A1 is 4 over 1 minus r. R is a half. We good to there so far? How we doing? We happy about that? Hey, let me give you something that'll probably make this easier to do. Rather than subtract the bottom, here's what you can do. I think you'll probably like this. Remember when you have a fractions over fractions, complex fraction, you just multiply everybody by the denominator, the 2. Multiply by 2, 2, 2, and it'll cancel right there. That might be an easier way for you to deal with it. Just multiply everybody by 2. It's okay. It's legal. I'm doing top and bottom of the fraction, so I'm not changing anything, right? Keeping the balance, top and bottom of the fraction, so nothing has changed. If you have a fraction and you multiply the top and the bottom of it, you haven't changed it, right? So then you get 8 over 2 minus 1, 8 over 1, 8. 8. Is that good?
No.
Questions I can answer?
I'm confused on like the one you flip it.
I did it a different way this time. Now you could do the normal though. You could just subtract these. What's 1 minus a half? The other way would have been just to make that a half on the bottom, and grab that and flip it, and it'd be 2 over 1, 4 over 1 times 2 over 1, 8. That makes sense. That's the other way. Good. Either way, it's 8. Either way, it's 8. All right. How about number 17? Let's try 17. 17 gets people a lot of times. Try 17. There's something that fools people on 17, and ones like this are on the final a lot of times. Like 17. It's not too hard, but it's got a little. It's kind of like what I usually choose for the final. It's not too terribly ugly, but it's got a little bit of a wrinkle to make sure you're paying attention. Specifically, watch the sign. So look at 17 and watch the sign. Oh, right. I'm with you totally.
Sorry.
There's no exponent in this formula. Yep, you're totally right. That's exactly right, Renee. Number 17, 1 minus a half plus a fourth minus an 8 plus dot, dot, dot. All right, find the R. Second term over first. Minus a half over 1, which is just minus a half, huh? So R is minus a half. We good? Question? All right, now, is the R between -1 and +1? Yes. It's a fraction, right? Fractions are between -1 and +1. Okay, so we can use the formula S sub infinity. What if it wasn't between -1 and +1? We would say diverges, done. Right? Diverges and done. So A1, what's A1? 1 over 1. Now here's the mistake people make. Minus -1/2. See, the double negative going to become positive. People forget the extra negative. There's the minus from the formula and the minus from the R. So it's 1 plus 1/2, isn't it? You with me? The double negative becomes positive. Like that. Okay, now how do we clean that up? I'm just going to multiply everybody by 2, top and bottom. Multiply by 2, multiply by 2. Right, because that doesn't change anything. When you multiply top and bottom by same number, the fraction doesn't change. These cancel. I get 2 over 2 plus 1, 2/3. We good? Does that make sense how I simplified that? Multiply top and bottom by 2. We good with all that? We're almost done with this. Let's jump to 19. So try number 19. What's R?
3 over 2.
Yep. Second term over first term, 3/2 over 1. Which is 3/2. So is that between -1 and +1? No. Because that's an improper fraction. The top's bigger than the bottom. That's 1.5, isn't it? 3/2 is 1.5. It's not between -1 and +1. It's bigger than 1. You with me? Right? You're supposed to have, we're talking about number line. R is supposed to be in here between -1 and +1. But 3/2 is way out here. It's at 1.5. It's not in the zone. So what is the answer here? Diverges. Meaning, if you added up these numbers forever, it would just get bigger and bigger and bigger and bigger and bigger and bigger and bigger. Just take off to infinity. It wouldn't add up to a finite sum. It would be infinite. It would just grow and grow and grow and grow because the numbers are getting bigger. If you add up bigger and bigger numbers forever, yeah, that's going to go to infinity, of course. Does that make sense? Are we good with that?
All we have to do is put diverges.
Yeah, that's all there is to say. That one diverges. Let's do 22 and we'll be done with this handout. 22, the sum from n equals 1 to infinity. See how you would know to use the infinite? The infinity symbol's right in the problem. Did I get off of 19 too fast? We got on 19? Everybody see how the R is not in the zone. It's not where it should be. Between -1 and +1. So try 22, the last problem on the handout. You're going to have to crank out the first term and the second term in order to find your R. So if you plug in n equals 1, you get 9 times minus 1/3 to the 1. Which is 9 times minus 1/3, which is minus 3. Is that too quick? Right? Because the 9's over 1, 3 goes into 9 3 times, minus 3.
Oh, yeah.
That's the first term. Find the second term. Plug in 2. Just 1. Is that good?
So first term, second term.
So the first term is minus 3. The second term is 1. Is that algebra working out for you? So then what's the R? Second term over first term. 1 over negative 3. Good. Now, is that in the zone? Yeah, sure. It's a fraction. It's a proper fraction. Proper fractions are less than 1. They're in the zone. It's less than 1 whole pi. It's 1/3 of a pi. Okay, so we can use, so the yes means we have a green light. We can use the formula. S sub infinity. Otherwise, you can't use the formula. A1 over 1 minus R. A1, what's A1?
Negative 3.
Yeah, this is A1. This is the first term, huh? First term over 1 minus R. Like that, huh?
Yeah. That's not fooling anybody.
These two negatives right here, what are they going to do? Become positive. Okay, and then I would multiply everybody by 3. And these cancel. Minus 9 over 3 plus 1. Minus 9/4. Is that okay how I simplify that? You guys okay with that? I multiply top and bottom by 3. Canceled right here. Excuse me. Minus 9/4. Is that good? That's what those all add up to be. That one has an infinite sequence of numbers, series of numbers that add up to be minus 9/4. Is that okay? You guys don't look extremely happy about that one.
I'm just focusing on the writing, you know.
Anything I can answer for you on that one?
I can't handle two emotions and write at the same time, you know. Sometimes.
Well, we have covered the material of the class.
Okay.
Any other questions about? I'm going to let you go early. Unless you have questions, feel free to hang out. Individual questions, I'd be glad to answer them. I think I've told you everything about the final. It's Monday at normal time, and you get a full sheet of notes. Go over the 5 practice exams. And, yeah, mainly the 5 practice exams, right? There'll be 1 question or maybe 2 from the geometric handout. This geometric handout will be due, and so will the arithmetic, on Monday. Start of the final, I'll collect them, and I'll grade them. They're 2 homework assignments, 10 points each. So I'll grade those.
Do you have some of the first handouts still?
Yes. If you didn't get first ones, I got them.
Yeah, I didn't.
Hey, come to my office. Yeah, if you didn't get the first one, come with me after class. I got them in my office. Yeah, if you didn't get the arithmetic, come with me. I've got it in my office. All right, let me turn the clickers on here. And we'll do the clicker thing. For the last time, the clicker. Hold on if you haven't clicked. All right, click A for apple. A for apple for the last time. That's it. All right. That's all your quizzers.
It's the last time for one whole semester, because if you're teaching...
Hang out if you got questions. I'd be glad to help you with some questions for the final. Otherwise, I'll see you on Monday with a big whopping final in my hand. Study hard.
I wasn't here on Monday to pick up my exam.
Oh, all my old stuff is right there.
And if we didn't get a sheet on Monday, just call you to your office.
Yeah. In fact, I'll go